Hello and welcome to this video, or this series of videos, which is going to be looking at the binomial expansion, and it's also going to look a little bit at the product rule of counting and permutations and combinations, because those things all work together quite nicely. This is part of the OCR Additional Maths course, and in this specific video we're going to look at the product rule of counting. So let's have a look at this example. There are 6 cards numbered 1 to 6. How many different 6-digit numbers can be made? So let's actually use a little diagram. Let's look at 6 cards. And let's consider what we can do. So there's 6 different digits, because they're numbered 1 to 6. So if we think about how we can make up this 6-digit number, we have 6 options for what we could use as the first card. That leaves us with 5 cards left as an option for the second card, 4 for the next one, 3 for the next one, 2 for the next one, and 1 for the next one. So the total number of different combinations are going to be found by multiplying all of these together. And when we work that out, we're going to have our answer for how many 6-digit numbers can be made. Now, one thing that's quite useful to know about here is a shorthand method of doing this, because as part of this topic, there's going to be many times where we're multiplying an integer by all of the smaller positive integers. And then there's a symbol for this, which is called factorial, and we write it as 6 with an exclamation mark. And so we can say that 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And so how many different 6-digit numbers can be made? There are 6 factorial ways, and most calculators have a factorial button, so it can certainly save you typing all that in. And that should give us the answer of 720. So let's look at this next bit. So how many different 4-digit cards can be made? So let's just think about 4-digit cards. I've still got the same 6 original cards, so I've got 6 options for the first card, 5 for the next one, 4 for the next one, 3 for the next one. So here I'm multiplying these together, but I'm not multiplying by 2 and multiplying by 1 at the end. So it's probably going to be easier just to do 6 times 5 times 4 times 3 rather than do 6 factorial divided by 2 factorial, but that would work either way. And that gives us an answer of 360. So let's think about the next one. So how many 3-digit multiples of 5 can be made? So again, let's look at our 3 cards. Now we've got an extra condition here because it tells us it must be a multiple of 5. And one thing we know about multiples of 5 is the final digit is a 5 or a 0. Now my 6 cards are numbered 1 to 6, so I don't have a 0 and I just have 1 5. So 5 must be the final card. So all I'm looking at then is ways of getting the first 2 cards. Now the 5 is fixed, so that gives me 5 other cards left. That could be the first one, and 4 cards left that could be the second one, and there's only 1 option there, so I could put in a 1. And so when I multiply these together, 5 times 4 times 1, there are 20 different 3-digit multiples of 5 that can be made. Here are some similar questions that you can have a go at, and then the answers to those. And then here's some more that you can have a go at. So good luck. And then here are the answers. We're going to explore some of the themes in this video in a bit more depth in the next one.